Now the next topic is radiation between two black surfaces and the view factor. What is view factor? The other name, which is it is also known as shape factor. This view factor is also known as shape factor, angle factor, geometric factor, and configuration factor. This view factor or configuration factor is purely function of shape, geometry, and orientation of the surfaces involved in radiation heat exchange. As per the definition, the shape factor is represented by capital F I J. There are two surfaces, let's say one surface is I and the second surface is J. The view factor in between these two surfaces I and J, which is represented by Fij, is the ratio of two quantities of the heat. The first quantity is the radiation energy leaving the surface I and reaches surface J directly to the total energy leaving surface I. There may be a other form of the F which is represented by Fii or Fjj. What does it mean? Fii or Fjj is the fraction of radiation energy leaving the surface I that strikes itself directly on the surface I. The second part of this topic is the radiation exchange between the two black surfaces. We are going to consider two black surfaces, surface A1 and surface A2. At the center we are going to assume, we have assumed small area dA1 on surface A1 and small area dA2 on surface A2. The normal from this surface A1 is N1 and it is making an angle beta 1 with the line joining these two area. And similarly on the other side there is a area A2. From that area A2 there is a normal N2. In between these two lines, normal and the line joining the two surfaces is angle beta 2. The distance between these two surfaces are S. The distance between these two surfaces is S. Now we are interested to find the value of net radiation heat exchange between the two black bodies. Net radiation heat exchange between the two black bodies. It can be calculated. It may be calculated by calculating or by finding the value of Q12 and Q21. What is Q12? Q12 and Q21 are the quantities of the heat. Q12 is the total rate of radiation energy which leaves the surface 1 and is intercepted by surface 2. It is the total rate of radiation energy which leaves the surface 1 and intercepted by surface 2. And similarly the Q21 will be the total rate of radiation energy which leaves the surface 2 and is intercepted by surface 1. To start, to find the relation for Q12 and Q21, we will start from the small value which is D Q12 and D Q21. These are the small quantities of the same heat. We have already assumed small area dA1 and dA2, dA1 on capital area A1 and dA2 on area A2. What we are going to use, we are going to use the definition of intensity of radiation and definition of shape factor. What dQ12 is the rate at which the energy leaving surface dA1, small area dA1. There was a small area dA1 on area A1. It is the amount of energy rate leaving the surface dA1 strikes the surface small area dA2, small area dA2. By the definition of intensity of radiation, intensity multiplied by projected area multiplied by solid angle. Solid angle on surface 2, it is represented by angle d omega 1 2 and it will be equal to area of small area dA2 cos of beta 2 divided by distance square. Similarly, small value of dQ1, dQ221, it is the energy, you can say the rate at which the radiation energy leaving surface dA2 this time leaving surface dA2 and strikes the surface dA1. It can be represented by using the definition of intensity of radiation. What is that? It is intensity of radiation multiplied by projected area multiplied by solid angle. In this case, at this time, the solid angle will be dA1 multiplied by cos of beta 1 divided by distance the square. From these two small values, dq1 and dq21, capital, which is the total value, total rate of radiation energy which leaves the surface 1. Now we are interested in the total value, total energy released by surface 1 and intercepted by total surface dA2 can be calculated by using the double integration over the entire surface area dA1 and dA2. How we can calculate this? This can be calculated by using one more concept which is known as, we know that ki IB, which is the intensity of radiation, is equal to EB by pi. We have already done this proof. For body 1 it will be like this, for body 2 it will be in the form of EB2 divided by pi. And by the definition of view factor क्या है? View factor is the ratio of two quantities. This is K12 divided by total energy radiated by surface 1, it is A1 EB1. We will use these two equations dq12 and dq21 and we will put here in these relations and solve it. After the simplification, by putting the value into the definition or the ratio in the form of ratio of the view factor, f12, shape factor of surface 1 with respect to 2, will be in the form of double integral over the surface A1 and A2. And we will also use the other equation which is known as IB is equal to EB divided by pi. By using these two relations, we will be able to find the value of Q net radiation exchange by the surface 1 and surface 2 between the two black bodies, which is Q12 minus Q21. We will put the value in the form of EB. It will be A1 F12 EB1 EB2 minus A2 F21 EB1 EB2. After the view factor, now what are the properties, or we can say what are the salient points about the view factor? The first point is for the flat and convex surface. For the flat and convex surface, the shape factor with respect to itself is always equal to 0. FII means the shape factor of the surface with respect to itself is equal to 0. The energy once leaving the surface never return to the same surface for the case of flat surface and convex surface. Second point for the concave surface. For case of concave surface, the shape factor with respect to itself means the shape factor Fi with respect to I is not equal to 0. There will be some value in between 0 to 1. The radiation energy coming out a part of the surface will be absorbed by the other portion of the surface. That's why FII is not equal to 0 for the case of concave surface. Third one is a salient point about the view factor is a reciprocity rule. If there are two surfaces, surface 1 and surface 2 are taking part in radiation heat exchange, as per the reciprocity rule, A1 F12, A1 shape factor of surface 1 with respect to 2 is equal to A2 F21. The fourth point is the summation rule. Summation rule, according to this, if n number of surfaces are taking part in radiation heat exchange, for that case, shape factor of one with respect to other when I varies from 1 to n will always be equal to 1. It will be always equal to unity. The conservation energy principle requires that the entire radiation leaving a surface I must be absorbed by all surfaces of the enclosure. The sum of view factor from I of the enclosure with respect to all surfaces of the enclosure, including to itself, must be unity. That's why Fij, I varies from 1 to n is equal to 1. Next is the superposition rule, or it is also known as additive rule. According to this rule, if there are two surfaces, there is a one surface having area A1 and there is another surface having area A2. If A1 is the surface which is radiating heat energy and A2 is the surface which is receiving energy, and A2 is further divided into A3 and A4. For that case, shape factor of surface 1 with respect to surface 2 can be written into the form of shape factor of surface 1 with respect to 2 will be equal to shape factor of surface 1 with respect to 3 plus shape factor of surface 1 with respect to 4. Then there is one more rule that is known as symmetry rule. According to this rule, if the geometry involves some symmetry, then the determination of the view factor is rather simple. We are going to assume a geometry in which length is equal to height or height is equal to length. For that case, we are going to involve three surfaces, surface 1, surface 2 and surface 3. When there will be a radiation exchange between the all surfaces, due to symmetry rule or with the help of symmetry rule, we can say that shape factor of surface 1 will be equal to shape factor of surface 1 with respect to 2 will be equal to shape factor of surface 1 with respect to 3.